In Essential Task 7.8, we are going to end our unit by describing various steps in the process of learning. The 5 terms that we are about to talk about today apply to not only just classical conditioning, but also other forms of learning like operant conditioning and observational learning. At least that's the case for the first 4. I'll return now to the task text, allow you to copy down the short portion in yellow before proceeding into the concept map. We'll start, as we typically do, all the way to the left and talk about the term acquisition. Acquisition is demonstrated when a learned response is first reflected in the behavior of the organism. And then again, that applies to more than just classical conditioning, which is the example here. This applies to all of the forms of learning. So, for example, if the very first time a dog salivates to the sound of a bell, you would then be able to say that that dog has acquired a new behavior. If, for example, you were electrocuted by Christmas lights, as we saw in the classwork, the very first time you then exhibit anxiety just by looking at Christmas lights, it would be clear that a new behavior is being reflected. That would indicate that acquisition has occurred. And again, that's classical conditioning, but it applies to operant conditioning. If a child is rewarded every 5th homework assignment that they complete, if it's clear that that behavior is being reinforced and it is clearly reflected in their behavior going forward, that that's acting as a motivator, then that child has acquired a new behavior. So regardless of which form of learning that we're going to talk about, acquisition simply indicates the first moment in which a behavior is acquired. This very much assumes that, for example, in the case of classical conditioning, that the bell immediately followed the food. If there's a delay between the neutral stimulus and the unconditioned stimulus, then acquisition is not likely to occur. If the reward or the reinforcement is delayed, it's not likely that acquisition can necessarily happen. So, for example, if a student completes 5 homework assignments, but you don't wait to reward them until the end of the year, then that might not necessarily be reflected in their behavior because the reinforcement is not immediately following the active target behavior. But nevertheless, acquisition is the very first time a behavior is reflected in the organism. The next concept is what we call generalization. You may have seen generalization in other contexts, and it's not inconceivable that you're using it properly. But the term generalization in the context of learning, so not social psychology where we talked about it before, but in the context of learning, is when an organism learns a new behavior, but they respond to situations that are different but somewhat similar to the situation in which they were rewarded. And in many senses, that's either in anticipation of receiving a reward or because the stimulus is similar enough in the context of the classical conditioning flowchart to elicit the same response. So thinking about Pavlov's dogs, yes, Pavlov's dogs learn to salivate to the sound of a bell, specifically the bell in the study. But it wouldn't be inconceivable that a doorbell that sounds close enough to the bell in the actual study could trigger drooling, at least initially. Chances are that after hearing the doorbell and not getting fed, those dogs would likely shift to the next term, which is called stimulus discrimination. But at least initially, it would not be inconceivable for a dog to drool to sounds that are close to the bell. For example, in another context, let's say one day you got sick eating chicken, and now every time you look at chicken, you feel nauseous. Well, maybe one day you see turkey, and turkey and chicken are obviously quite similar, and the sight of the turkey triggers that sickness. Well, turkey was not the neutral stimulus that is now a conditioned stimulus triggering nausea, but it's close. As a result, you could generalize that learned response because the stimulus that you're interacting with is close to the original. Let's say a parent is rewarding their child every 5th math homework that they complete because for whatever reason, this parent really emphasizes the importance of math. This child, though, unknowingly completes 5 science assignments thinking that they're going to get rewarded because they've been rewarded for their math assignments. When they realize that, wait a minute, I'm only getting rewarded for my math assignments, I don't get rewarded for 5 science assignments, it's not inconceivable that they shift from generalizing and completing all of their homework, waiting for responses, to what's called stimulus discrimination, where the organism learns to differentiate between exactly what is necessary for the, in this case, reward to be received or the reinforcement to be received. Stimulus discrimination is when you learn to respond only to one stimulus, only to one situation, and to ignore things that are similar. In the case of Pavlov's dogs, you would clearly see this when, after enough time has passed, those dogs only drool to the sound of the bell in the study, and that doorbells, cell phones, alarm clocks, other sounds, metronomes, sounds that are similar can be discarded and ignored. We can discriminate against all of those sounds because the dog, at least at some point, will eventually acknowledge that those sounds are not indicators of the arrival of food. A child, for example, who was previously rewarded for doing math assignments will very quickly learn to discriminate and say, okay, I can ignore my science assignments, at least in the context of anticipating a reward, and know that my behavior is only being reinforced after 5 math assignments. So whether it's, again, that classical conditioning flowchart or that reward-based operant conditioning phenomenon, stimulus discrimination can be applicable to both. We referenced briefly this 4th term when we talked about schedules of reinforcement, which was a reference to the reinforcement schedules offered by B.F. Skinner that take into consideration variables such as timing or the repetitive nature of the behavior in determining how to effectively teach an organism a behavior. We specifically denoted back in that essential task that variable ratio, the equivalent of what you would do at a casino playing a slot machine where you crank the lever hoping that each play could potentially be a jackpot, is the most resistant to extinction. Extinction is the formal word when a learned behavior is no longer reflected in an organism's behavior. It's been eliminated. There are really 2 different reasons this could happen. One, it's been so long since the classical conditioning first occurred, and that's what the example here is at the bottom. It's not inconceivable that baby Albert's fear of animals could go extinct, because as that child ages, obviously the parents or guardians are not going to continually pair loud noise with the presence of animals. That eventually is going to stop. You could conceivably see that behavior go extinct. Let's say you did get sick eating chicken. After so many years, so many months, it could get to the point where you've been around chicken, maybe you've eaten it again and you haven't gotten sick, and now you've overcome that conditioned response of nausea to the presence of chicken. That behavior would have gone extinct. So if enough time has passed since the pairing occurred, and those behaviors are not being repetitively paired in and of themselves, you could see extinction occur in the context of classical conditioning. That also works with operant conditioning. If, for example, as a child goes from 8th grade to 9th grade, their parents are no longer rewarding them for completion of math assignments, that child might choose to no longer complete their math assignments because the reward is no longer being provided. So if the pairing's been months and months, years away, or the reinforcement is simply stopped, you could see an organism exhibit extinction where that behavior is no longer reflected. The last term is one that applies more so to classical conditioning than any of the previous. So this is a phenomenon that we primarily talk in the context of classical conditioning, but it's called spontaneous recovery, and it is in many ways what it sounds like. It assumes extinction has occurred. So let's say baby Albert is no longer exhibiting a fear response to animals. Extinction has clearly occurred. It's been years since the study. He's seen animals every single day going outside. Maybe he has a pet dog. Clearly, the behavior has gone extinct. But seemingly out of the blue, really with no discernible reason, he comes across a dog, and next thing you know, he feels that anxiety, or he comes across a white rat or a rabbit, and he feels the same anxiety that he experienced in the context of the study, even though there's been no further conditioning. The neutral stimulus of the animals and the unconditioned stimulus of the loud noise have not been repaired. There's been no second learning here. The child just simply exhibits that fear response, seemingly out of the blue, even after feeling as though that behavior has gone extinct. There are plenty of individuals who legitimately experience a diagnosable phobia, go through treatment methods to hopefully have that behavior go extinct. Then seemingly out of the blue, months later, years later, they see a clown, they see a spider, whatever it is that led them to go to behavioral therapy, and that behavior seemingly comes back. Chances are the behavior is going to be weaker. That's typically the case. The response is not typically as strong as it once was, but hopefully that behavior then goes away again if it's something in the context of, for example, a phobia. But we call this phenomenon spontaneous recovery, where a behavior has seemingly gone extinct. Relearning has not occurred. That's very important. No further conditioning, but that behavior returns typically quite a bit weaker, but nevertheless still reflected in that behavior. And then it typically goes extinct again.